Welcome to Mimi's Math Channel. This video will help you with your final exam review. I'm going to show you how to use Desmos for logs and exponents. So for your first example, we're going to verify inverse functions of logs. I'm going to take my function f of x and I'm going to type that in my first row in Desmos, and I'm also going to take the function g of x and I'm going to type that in the second row of Desmos. And then I'm going to show you how you can tell whether or not they are inverses of each other. But if you just wanted to know how to do the composition method, what I'm doing is I'm actually taking f of g of x. I'm taking the g of x and I am substituting all of this function where the x is for my f of x. And then I turn around and I do the same thing for f of x and substitute that in for the x for the g of x. If you are using composition method, your answer should end up being an x. In Desmos, I typed in my f of x, which is the red one, and then my g of x, which is the blue one. And what you're looking for is that those graphs actually reflect over your line of reflection, which is known as y equals x. It has to be that positive slope. Sometimes they'll try to trick you on these tests and they'll have the slope going downward. That is not y equals x. Another way that you can do it is you can just click on a graph in Desmos and it will automatically start giving you points. So if I click on this point, -2 and 0, in order to have an inverse, my x's and my y's will have to swap. So if I go to the other graph, I should have a point at 0, -2, and I do. I personally like to look for 3 points on each graph, but once you click on it, if you don't see any more, then, well, like here, I do see a point. I see 8 and 0. So that means on the other graph, the x's and y's should switch and it should be 0, 8. So if I click up here, that is true. So 2 for 2. I'm going to show you another way. If you go just to get that third point. So if you click over in the row over here, hit that gear setting, click the table, and you can also see some points here. So we saw 0 and -2. We didn't see 2 and -1, or at least I didn't. So let's just click this again. So now I see some points popping up here all of a sudden, including this one. So I just needed 3 points. And now since I see this 2 and -1, if I go over here and I have to pay attention to how it's counting, if I go over to -1 and up 2, I should also see a point. If you can't really tell by clicking on the graphs, just go over here, click the gear, choose the table, and then just look at it that way. So I know at 0 and -2, if I look at the blue graph, -2 should flip where the x is, and then 0 should be y. And then I have a 2 and a -1. So that means if I switch it, I'm going to have a -1 and a 2. If I put that 8 in there, I have 8 and 0. And then again, when I switch it, 0 and 8. Now that tells me that these two are actually inverses of each other. Well, what would happen if I change this 1 to a 5? Now I see that I can't take these graphs and flip them over that line of reflection on top of each other. You can just look at it and tell. And you could click over here and go to the table just to verify. It says when x is 0, then y is -2. So that means at -2 for my other graph, the y should be 0, but it's not. So that's another way that you can just double check your work. And it says when x is 2, that y should be -1. So that means over here, -1 should have a +2. It does not. So these are not inverses of each other. So for example 2, I'm trying to find the characteristics of both a log and an exponent function. So we're going to start off with the log one. Using that same example, if I go to Desmos and type that information in, this is what my graph will look like. If I'm looking at the graph, I can see that it's actually moving upwards this way. However, it's leveling out vertically here. Well, that tells me that I'm going to have a vertical asymptote, meaning it's going to cross over that x-axis. And again, you want to be careful what you're counting by, what units. I see that this is going to be x is equal to -1. So I'm going to just change that so I can see my asymptote. This is going to help me to determine my domain, my range, and other information. So we're going to go ahead and write that our vertical asymptote is going to be x is equal to -1. And for my domain, I am looking at how far can I stretch this graph to the left and to the right. Well, to the left, I can't go to -infinity because the asymptote is blocking me. So since I read from left to right, I'm going to start at this asymptote from -1, but I can keep going on to +infinity. and this is going to be in parentheses. My range, however, is not restricted. I don't have any type of asymptote. So if I straighten this graph out all the way down and all the way up, it can go on forever. I read a graph from left to right and from bottom to top. So this would be negative infinity to positive infinity. My interval of increase or decrease is the same as my domain. But which way am I going? Am I increasing or decreasing? I am increasing. I'm never decreasing. And I'm increasing from -1 to positive infinity. All right, and now I'm looking for my x and y intercepts. I love Desmos for that because, again, if you just click on the graph, it'll just populate different things for you. My y-intercept is where the graph crosses the y-axis, and my x-intercept is where the graph crosses the x-intercept. Now, for the x-intercept, your y has to be 0, and for the y-intercept, your x has to be 0, and it's shown as coordinates. Your x-intercept is very important when you're trying to find your positive and your negative intervals because this is telling me at what point it's going to cross into the positive area. I look at it as, see, these are positive numbers. Even though my positive and my negative intervals are my x values, it just helps me to see it better if I am trying to look above my x-axis because it's positive, and then below my x-axis is negative. These values, when I'm talking about positive and negative, are my x values. Where is x positive? From 8 up to forever for this graph. This is not included. It's just going through it. This line consists of a bunch of different points. That's why I'm going to make sure I use parentheses. So from -1 all the way up until 8, I'm using parentheses. And what you will notice is that 8 repeated. In behavior is what's going on with the graph. If I'm going on the x-axis with this graph, what happens to it when I turn it up and down, which is my f of x? F of x means y. Well, as I'm going towards -1, because it never gets to negative infinity in this case, then this arrow or this graph is going down to negative infinity. Well, that's going to the left. What would happen if I am actually going to the right? So if I took this and I'm going towards positive infinity on my x-axis, what would happen if I took the arrow that's closest to me and I straighten it up and down? Well, it's going to be going up. So both of these are going to be positive infinity. Now, the next example that I'm going to do is exponential function. On this one, what I want to do is look for my asymptote. Well, I see it's not vertical this time. Now it's leveling off horizontally. Well, if I were to keep going, where is it going? It's going over the y-axis. So I know it's going to be y equals something. Count my units and I see that y is -1. And then I'm asking the question, what's my domain and my range? Well, this time I don't have any restrictions left and right. So domain are my x values. So that means I can go on for all real numbers. This graph can consist of every number that's on my x-axis. My range, however, cannot go from negative infinity to positive infinity because that asymptote is blocking it. So that means that starting from bottom to top, which is really my asymptote of -1, I am going to say that my range is from -1, but I can keep going all the way up to positive infinity. For this graph, what am I doing? Am I increasing or decreasing? I'm reading from left to right, bottom to top. I am going up. So I'm increasing, and it's going to be the same as my domain. I'm increasing from negative infinity to positive infinity. My x and y intercept, again, if I just click on the actual graph, it will give me points. This point is -2 and 0, and because it's on my x-axis, that is my x-intercept. And then this one is 0 and 8, and because it's on my y-axis, it's my y-intercept. You should notice that example that we did a few minutes ago, it was swapped around. That's because exponents and logs are inverses of each other. I need to know my x-intercept because that's going to help me with my positive and my negative intervals. And I'm asking myself, where is my graph negative? Well, this time I have this horizontal asymptote. Does it affect anything? No. In this case, it doesn't, because remember, positive and negative means that that's my x value. So I'm not looking at y values. So it can go from negative infinity all the way to -2 in the negative interval portion. For positive, it goes from -2, and then if I stretch this out to the right, it will go on forever. So -2 to positive infinity. And when I am referring to my end behavior, as x is going towards negative infinity, this arrow that's closest to it, if I straighten it up and down, well, it can't go to negative infinity. It has to go to whatever that asymptote is, which we said was -1. And going in the opposite direction, as x is going towards positive infinity, this is this graph. If I am trying to straighten it out going upward, the arrow closest to it is going to positive infinity as well. So both of these will be positive. Now, I don't know if you noticed, but like in that first example, well, let's just look at this. So this example for range means your y values. F of x means y. Do you notice that both of my y's are the same for both my range and for my end behavior? If you went back up to the other example, you will notice for domain, which are my x values, that they are also the same as the x values that are in my end behavior. Again, if you just look and you compare the two examples, you will see I'm using the same numbers. The only difference is because they're inverses, they're swapping positions. So domain actually has a number and an infinity sign, whereas in the exponential one, the range has that. And then for the log, the range is always all real numbers, but for exponents, the domain is all real numbers. My asymptote for exponents is y equals that number, and if I go to the logs, x is equal that number. You get the gist of it. So those are inverses of each other. So let's go on to the last two examples, which is solving logs and exponents. This is my manual calculations for solving a log. Well, in this case, a natural log. So how I would suggest that you enter this in Desmos is this side, the left-hand side, you put this in its own row. And on the right-hand side, you put this in its own row. Now, what I will warn you against is you notice in front of this natural log of 3, I don't have a graph. So I would put y equals so that you can get the graph. And the reason you want that is because you want to see where those two intersect so that you can solve for x. So if I click on this, I see that x is 4. If I go back to my manual work, I already knew that the answer was 4. So let's just double check our work. I'm going to copy this down to another row. And in the place of x, I am going to put a 4 there. And since I'm multiplying, you want to use parentheses. And I also have an x here, so I'm going to put a 4. Here, I don't really have to use parentheses since I'm adding, but it's just good practice. Does this side of the equation equal this side of the equation if I were to substitute it with a 4? And as you can see, yes, the decimal equivalent is the same. So that's how you know this is the correct answer. And you would do the same thing. So you would just take this side and you would put it in one row, this side and put it in another row. This time I didn't have to use a y equals. It just automatically gave me two graphs. You want to see where those two graphs actually intersect. If I just click on it, it just happens to be there for me. I see that this is my x value. Remember, I'm looking for x. So let's just copy this one. And then I'm going to replace that x with this value. I can copy that as well. And because it's next to the 3, I'm multiplying. So I'm going to put a parentheses. And then I'm going to do the same here. I'm just going to copy this one down. And in the place of x, I'm going to use this same information. And I notice, yes, they have the same decimal value. So I know that x is this number. This is my x value. When you're checking your work, do not take the check work answer. Whatever it said on the graph that x was, that's your actual answer. And again, if you just click on a graph, it will show you the different points there. All right, thank you so much for watching. Please remember to like and subscribe. Have an awesome day.